So now we're actually going to solve a system of three linear equations and three variables. So here's our problem. We want to solve the system x plus 2y plus z equals 3, 3x plus 4y plus 9z equals negative 9, negative x plus 2y minus 9z equals 21. So we got three equations, three variables, x, y, and z. We want to find a value for x, a value for y, and a value for z that works in each one of these three equations. And I'm just going to number them 1, 2, and 3 as we work with them. So the strategy we're going to use is basically substitution, but it's just going to be a little bit more complicated because we're dealing with more variables, more equations. To get started, what we have to do is we have to isolate one of the variables in one of the equations. Doesn't matter which variable, doesn't matter which equation you choose, and you kind of want to make life easy for you here. I'm going to choose to isolate. So I choose to isolate that x in equation number 1. So I'm going to recopy equation 1 here. It's because it's really easy to isolate that x. And by isolating it means I'm going to subtract 2y, subtract z from both sides. So x is equal to 3 minus 2y minus z. Okay? And then I'm going to substitute, I'm going to use this idea of substitution into both of the other equations. So I'm going to take both equation 2 and equation 3. So equation 2 is 3x plus 4y plus 9z equals negative 9. Equation 3, negative x plus 2y minus 9z equals 21. And the idea for my substitution comes from what we did right here. So in each of those, I'm going to replace the x with that expression. So in number 2, I have 3 times 3 minus 2y minus z plus 4y plus 9z equals negative 9. And I want to work on this a bit. Let's clean it up a little bit. I got to distribute the 3, right? So I have 9 minus 6y minus 3z plus 4y plus 9z equals negative 9. I'm going to combine like terms, so I have 9 minus 6y plus 4y minus 2y minus 3z plus 9z plus 6z equals negative 9. And I think I'm going to go ahead and subtract 9 from both sides. So I have negative 2y plus 6z equals negative 18. And maybe what I'll do is I'll multiply both sides by negative 1 to get 2y minus 6z equals positive 18. So I substituted in for x, and I clean things up a bit. And notice here I have an equation in just y and z now. Now we got to do that same kind of work with equation 3. I have to substitute in for x, but now I have minus x, so I have minus 3 minus 2y minus z. What's critical here is that we put that expression for x in parentheses, because we're going to have to distribute that minus sign in front through each one of these terms. Let me copy the rest. Plus 2y minus 9z equals 21. So this is like the easiest kind of mistake to make where you might forget to put the parentheses, and then you'd forget that you actually have minus 3 plus 2y plus z plus 2y minus 9z equals 21. So maybe I just want to highlight that fact that you got to distribute the minus sign. And now again, I'm going to combine like terms. I got negative 3 plus 4y minus 8z equals 21, or 4y minus 8z, adding 3 to both sides is 24. So notice that both my equation 2 and my equation 3 now have become equations that involve just y and z. So I'm gonna bring them together. And what we want to do now is solve the resulting system of two equations and two variables. So it turns into a situation we're familiar with. I guess this is what was my original equation 2, my original equation 3. I can take equation 2 here, and 2y minus 6z equals 18. I'm going to divide by 2 to get y minus 3z equals 9. And now if I isolate y equals positive 3z plus 9, I can substitute into the other equation. So I'm using old-fashioned substitution with two variables. So I'm going to replace y here. So I have 4 times 3z plus 9 minus 8z equals 24. So this was the idea for my substitution. And I have 12z plus 36 minus 8z is 24. Combine like terms again. 12 minus 8 is 4z plus 36 equals 24. 4z is going to be, let's see, 24 minus 36 is negative 12. So here I have z, when I divide both sides by 4, is negative 3. Now I can substitute into y equals 3z plus 9 to get y equals 3 times negative 3 plus 9 is negative 9 plus 9 is 0. So I have a value for z. I now have a value for y equals 0. And don't forget, we need a value for x, because there were 3 variables to begin with. And to get my value for x, I'm going to go back to the first equation where we had x isolated. X is equal to 3 minus 2y minus z. So x is equal to 3 minus 2 times y was 0, minus z is minus a negative 3. And so it looks like x is actually 3 plus 0 plus 3. I get x is equal to 6. And I guess I'm trying to squeeze onto one sheet of paper here. X is equal to 6. So my solution is going to be x equals 6, y equals 0, z equals negative 3, which you can write in this way, or you can express your solution as an ordered triple and just write 6, 0, negative 3 in that compact form. And there we did it. We used a substitution process to solve this system of equations in 3 variables. And my answer again is 6, 0, negative 3. That's written down here on the right.